Alright, this is Codebender. Just going to show you around a little bit. This is my page. You can see all the files I've created. There's a whole bunch of them. Okay, and then now you see when they were modified last. You can sort them by different things, date created, such like that. You can sort public or private. I think all of them are public unless you have a professional account. And then you can upload personal libraries. We'll talk about that later. And then you can create a sketch or you can upload a sketch. Okay. Some other important things that we'll use later, we have examples and libraries. Okay, this is very useful because sometimes if you want to learn how to use something, like here's some basics. Okay, and so this is the kind of the basic Arduino, most basic Arduino program called Blink. And so this is the one I actually had you start with on the last one. And so you can actually get them here. You can make edits to it from here and run it on the Arduino, or you can edit it. Or you can edit it here, or you can make a clone of it, copy it as your own, and then make edits to it. Okay. And then what you'll also notice though is there's lots of examples. So let's say that we want to learn how to do some other kind of thing, like maybe use some kind of display, or work with like USB control, or learn about different sensors, or some kind of control thing. There's lots of stuff we can do here. And then there are built-in libraries here and external libraries here that you can search for. There's lots of libraries. There's lots of good stuff here. A lot of it is far beyond what we're going to do anytime soon, but these sample programs can be really useful for us. And so if you're curious about something, you could search examples here. Also, Google is one of your best resources too. I mean, if you type in, let's say, Arduino Blink sketch, okay, you're going to get hundreds and hundreds of things. Whatever you want to do on Arduino, if you want to find an example, you can find it online. Now the reason I tell you this is not because I want you to go searching every time you have something to do, but if you get stuck, this is a great resource, the internet. You can find a lot of things online, and your goal is not, again, to do the thinking for you, but to learn from it. So like if you get to a point and you're not sure how to make something work, search the internet, find a solution. Okay, so anyway, back to Codebender. Alright, we're going to go ahead and create a new sketch. Okay, actually let's go ahead and we'll use the Blink example. Okay, we'll start from there. So I'm going to click to clone and edit this example. Okay, and the first thing you're going to notice is that the code here looks different than it did when we were working on when we were working on Python. Okay, and this is actually a different coding language. This is called I think this is pretty much C++. Okay, and so it's kind of a version of C++ that's optimized for Arduino. So this is what we're using. Okay. Now, a couple things, you can edit the title over here, call it whatever you want. You can save the title. And then you can also add files, okay? Now, I'm going to recommend you steer clear of this button, because until we actually need it, this can only cause you problems, okay? Because sometimes you'll actually accidentally add a file and be editing that instead of your sketch, and then you'll try to run it and nothing will change. Okay, some other things, if you want to put a description here, you can share it, you can make a discussion apparently. I don't know about what that's about, but that's something we can explore. And then here we have our program, and then we can verify it to check to see that it is good to go. Okay, so it's selected Arduino Uno, so when you click verify code, you're basically checking to see that this is a program that the Arduino Uno would understand. And then you can also run it on Arduino. Now, if you click run on Arduino and you have the Arduino hooked up, it's going to automatically verify anyway. So the only reason to do verify code is if you don't have an Arduino hooked up, or if you're not ready to write it to the Arduino. If you're ready to send it to the Arduino, click this one because it's automatically going to verify it. Okay, and so here we have a program. right off the bat, you might notice that all the lines have semicolons at the end, okay? And this is something, one way that C++ is different than Python. In Python, we didn't use semicolons. In C++, you have to end the line in a semicolon. If I change this right here and I click Verify Code, I'm going to get an error, okay? And you can see the error popped up right here. Okay, it says expected something or other 13, and then it says expected semicolon after top level declarator. Okay, it tells me what line it happens on, line 10. Okay, and so right off the bat, if it's not working, if you look down here and you kind of read through it and try to understand it, you're going to figure out what the problem is. Pretty clearly, it tells me I'm missing a semicolon. So I fix that semicolon, verify code, and then we're good to go. Okay, and there's some other differences. So like in Python, when we create a variable, you could just create a variable. In C++, when you create a variable, you have to tell the software, you have to tell the Arduino what type of variable it is. And so oftentimes when we're storing a number in a variable, it's an integer. Other times it might be a float. Okay, but most of the time we'll use integers. Okay, and then the basics of an Arduino program. Any Arduino program has to have a couple basic lines of code. So I'm going to just erase it all the way to the basic lines of code. Okay, so any Arduino program you write needs these lines of code. You need a setup function and a loop function. Here's what the Arduino does. When it starts up, it runs the setup function, and then once it finishes the setup function, it's going to go to the loop function and it's going to run it forever. Okay, now it's up to you how you use these things. Sometimes we can write all of our programming in the setup function. Sometimes we'll put it all in the loop and not do anything in the setup function. But basically, these two functions have to be there for the Arduino to understand the program. And then and I'll kind of explain like why we do it that way as we go. Okay, a couple other things. If you want to do a multiple line comment, you can do the slash with the star after it. Okay, and so this is a multi-line comment. Okay, comments don't affect the code. Okay, as you're doing this and as I'm like checking stuff off, I really need to see the comments in your code. Okay, it's important to include comments. They help you understand things, and they help you understand things when you come back to it later. So if you want to make a comment that's more than one line, that's what you're going to do. If you want to make a comment that's only one line, you're going to use the double slash. Okay, so double slash, this is a comment. Okay. And so we'll delete my nonsense comments here and read through theirs. So this is a program that turns an LED on for 1 second, then off for a second. Pin 13 in the Arduino actually has an LED connected, and so when you run this program, you can see an LED blinking on the Arduino. The way that it works is that we assign the number 13 to the variable we called LED. And then what we do, and these are a couple of things that as we get used to using Arduino, we're going to start to understand. So on line 15 here, we have to tell Arduino how we are going to use the pin. Okay, so we're going to use pin 13, right? LED represents the number 13. We're using pin 13 as an output. Okay, which means we're using it to power something or send out a signal. Okay, and so we use this function called pin mode to assign 13 as an output. Okay, we can also assign pins as an input. We'll get there later. Okay, so assigning pin 13 as an output, if you were to take this piece out, it should still run. Okay, but what's going to happen is that it won't be able to write to pin 13 very well. And you might have the LED not lighting up all the way, some weird stuff could happen. Okay, so we want to assign it as an output. And then, so remember, the setup just runs once. And then when the setup's finished, we go down to the loop, and this loop goes forever. And so what it does is there's a function called digital write that tells us to turn that pin 13 on or off. When it's high, it's turned on. When it's low, it's turned off. So pin 13 gets turned on. We wait for a second. Then it gets turned off. We wait for a second. Okay. Now think about what might happen if you took out this line here. Okay, that tells us to wait for a second after we turn it off. We write it high, we turn it on for a second, we turn it off. Then we go back around and do it again. We turn it on, wait a second, then turn it off. And so what's going on here is it's actually not waiting in between turning it off and then turning it back on. And so what's going to happen is it's just going to look like it stays on the whole time. So you need this delay after writing it low, so you can actually see it when it's turned off before it turns back on. Okay, and so it's going to execute this loop until you unplug it, essentially. Okay, or until you write something new, or if you press the reset button, it will start the program over. Okay, so we've basically we actually had a lot that we learned in this video. We learned that there's a setup function that runs at the beginning, a loop function that runs partway through. Okay, the function is anything contained between these braces. Okay, and then we have here where we're writing the pin high and low. Okay, and then here where we're causing it to wait. Okay, now the number here in the delay represents the number of milliseconds. So 1,000 milliseconds is equivalent to 1 second. Okay, so 5 milliseconds would be equal to, or 5,000 milliseconds would be equivalent to 5 seconds, and so on. Okay? And so this is the basics of Arduino. We'll come up with more videos as we go. Hopefully this was helpful, and hopefully this is enough to get you started.